Back in episode number 104, I reviewed a Soundcraftsmen RA7501 power amplifier. In that episode, I mentioned that Soundcraftsmen offered 3 amplifiers with identical specs in that line, which would be 250 watts into 8 ohm loads at not more than 0.09% THD from 20 Hz to 20 kilohertz, and the frequency response over that range was listed as plus or minus 0.25 dB. What made the amplifiers different was that the base model, the RA7501, had a protect LED, it had a power LED, and it had clipping LEDs for each channel. The next model up, the RA7502, had those LEDs, plus it had an additional very proportional LED for each channel, which would turn green when the power amplifier was switching on its higher voltage rails, and that was part of its Class H amplifier design. And it also had an LED power meter. The top of the line RA7503, which sold for $1,149 back in 1981, or about $4,000 today, boasted all of those LEDs in addition to an LED spectrum analyzer. Those of you who have been watching this channel for a while know that I have a thing for LEDs and power meters. So it would not come as a surprise if I decided that it would be nice to have one in my collection. What I found out after searching for them is it's a pretty rare piece. They just don't come up for sale. I kind of had given up on finding one, and then one day I did a search on eBay and one popped up for sale. It had been refurbished by the seller, who seems to know what he's doing. I made an offer, he made a counter offer, and well, here it is. I had a real good experience with the seller, and he does have a website. Eric's website is called Stereo Phoenix, and I'm going to put a link to it in the description below. Now, he specialized mainly in Soundcraftsmen gear, at least when I looked on it last, that's what he had, but you never know what he may have on there, and I would definitely recommend checking out his website, especially if you like Soundcraftsmen gear. The RA7501 that was used in episode number 104 is one of the rare pieces of gear that I review that I actually own, and it was pulled from service in one of my systems to make room for another power amplifier. So basically the RA7501 just sits on a shelf. Occasionally it sees duty when I need some higher power capability. So I really did not need another power amplifier, although the thought of running both power amplifiers in mono with the capability of delivering 750 watts into 8 ohms is intriguing. I'm not sure I could do that for very long because I'd like the things to match, and with one having all the LEDs and one not having the LEDs, it might drive me a little crazy. But anyway, I do have that capability, and maybe one day I will play around with that idea. But for now, this amplifier is replacing a Bryson 2B LP that I have. I've done reviews on them. I actually own 2 of them. I ended up selling one of them to help cover the cost of this guy, and this is going to go where it was in one of my systems with the clipless Scalas, which really do not need 250 watts per channel capability, but I like looking at LEDs and stuff. So anyway, I also thought it would be a great topic for a video to review the all original 44-year-old RA7501 to see how it compares with the recently upgraded RA7503. And that will be what this video is about. I will show some of the refurbishments that were done, and then of course there will be data comparing how the 2 units performed, and finally there will be a little conclusion. Here is a more intimate view of the Soundcraftsmen model RA7503 Class H amplifier. Let's start over here on the left with our power on-off switch. We do have these very proportional LEDs that turn green when the very proportional circuitry is being engaged, and that's for either channel. And what that is kind of what makes this Class H, in that as you need more signal because you want to play louder, your input signal is increasing, so then of course your output signal is going to increase. And what that circuitry does is adjusts the output voltage rails so that they go from, say, 45 volts to 90 volts. So it kind of conserves power when you don't need it, and then when you need it, it goes to the higher rails and allows you to be able to get 250 watts into 8 ohms, or they say 750 watts into 8 ohms bridged as a monoblock. We also have true clipping LEDs for both channels. Now our gain controls right here in the RA7501, they're detented. You'll see in a little bit a picture of what was replaced, and he did replace these pots. These are not detented. They're both work the same. It's just one has little detents and one doesn't. So I don't really have a preference either way. We also have our true clipping indicators for each channel when it detects that it's in clipping. This obviously is our spectrum analyzer display. You can either choose channel A to be displayed on the spectrum analyzer, channel B, or you could have both of them displayed at the same time. This obviously is our LED power meter, and it has different markings for whether it's 8 ohms, 16 ohms, or 4 ohms, and then whether you're in mono or stereo. And then it does have a protect LED that will flash when it's first powering on and then it goes away. Or if it ran into some problem, it would shut down and flash that LED. You can also see that it has holes here for rack mounting into standard 19-inch racks. This is the rear of the RA7503. Now, Eric had modified the original power cord that just had, a standard power cord sticking out, and he put an IEC kind of power cord AC adapter in there, which is really nice to have. This is the rear of the RA7503. Now, if you watch the RA7501 video, it looks the same other than that power cord changeover. And then I modified this because the one I had didn't have this cover over it, so I kind of made something so I could change it. And this is for whether you want to use it in mono or a stereo, and you can run either this in a balanced mode or unbalanced mode depending on what kind of 1/4-inch jacks you use, and it explains everything rather nicely. This is the inside looking down of the RA7503, and this just kind of shows the layout. This obviously is the rear, and this is the front of the unit. These are all the parts that were replaced by Eric. Remember, I had bought this off of eBay, and he did a really good job of replacing all the electrolytics. He replaced the screws, the power cord, and a couple bolts, I guess, along the way. And then these were the 2 pots that he replaced, and I guess at least 1 resistor, and some ICs. Right now, we're looking at our standard THD SNR plot at, you guess it, 1 kilohertz, with the 7503 putting out about 5 watts into 8 ohm loads. The gain control has been set for about 29 dB of gain, and the difference between the 2 plots is I'm using the balanced inputs here on the left and the unbalanced inputs on the right. Really not that much difference between the 2 overall. The balanced inputs actually looks a little worse than the unbalanced inputs as far as the SNR, but THDs are pretty much the same. Right now we're looking at the difference between the 7503 and the 7501. The 7501, once again, is all original. Now they're both putting out 5 watts into 8 ohm loads at 1 kilohertz. Gain controls have been set for about 29 dB of gain. And you can see that the 7501 looks a little bit better than the 7503 as far as the SNR. THDs are pretty much the same for all intensive purposes. You can also see that the left channel has a bit higher noise level here compared to the 7501. And other than that, they look kind of the same. Now, I will point out right here at this red harmonic here. It's about 2300 hertz, and that'll come into play a little bit later. But notice that there is one here, and there's not one over here at around, I believe it's 2300 hertz. So there's a reason for that, and I'll get into that in a little bit. Here is the frequency response from 20 hertz to 20 kilohertz of the RA7503, with it putting out about 5 watts into 8 ohm loads, just showing the difference between the balanced and unbalanced inputs. Really not any significant difference at all. Maybe the unbalanced inputs have a little bit better frequency response, but really not any difference in their frequency responses. If we come over to the RA7503 balanced inputs on the left and the RA7501 balanced input on the right, you can see that the frequency responses look pretty much the same for all practical purposes. I could have done a little bit better job with balancing the two channels here, but it's pretty darn close between the two, and we're still talking at 20 kilohertz. We're under 0.15 dB of loss. Here we have the difference between the 7503 and the 7501 at very high power levels. They're rated at 250 watts into 8 ohm loads in stereo mode, and you can see we're right about that for both of them. Really not any significant differences between the THD or the SNRs overall. I guess the SNRs are a few dB better for the 7501, but overall they're both performing quite well. And this slide shows the difference between the 7503 here on the left and the 7501 on the right. Once again, both using the balanced inputs, where the clipping LEDs started to come on. So this is right where the clipping LEDs came on. You can see that the 7503, actually it looks worse, although the THD is not really that bad at all, and the SNRs are really not that bad. But you can see it looks worse than the 7501. Now, the clipping indicators were coming on the 7501, so that's where I took this snapshot. And really, it probably could go up higher. I'm guessing there's an adjustment for the clipping LEDs accuracy. I did not adjust it on this, but I know if there was an adjustment for the clipping indicators, I would have adjusted it on the 7503. So it just kind of just shows another little difference between the two. One of the measurements I have been doing on amplifiers lately is the dynamic headroom measurement. And it kind of gives you an indication as to how much of a burst of power the amplifier or receiver or integrated amplifier, for that matter, can put out. Now, I could not find a specification from Soundcraftsmen on it. However, I found a test report from 1981 where they measured a dynamic headroom of 1.94 dB. In my case, I measured 1.83 dB. And what that means is that for a very short burst of power into 8 ohm loads, you could get as much as 380 watts. And remember, it's rated at 250 watts. So that is not bad. Right now, I have the RA7503 and RA7501 running as monoblocks, putting out about 5 watts into 8 ohm loads. The RA7503 with all the new capacitors is the left channel, and the RA7501, all original, is in the right channel mode. Now, it's fairly easy to hook them up as monoblock amps, and what I had to do on the right channel was adjust the gain just a tad. It had a little bit more gain when it was operating as just a regular stereo amp, and I went to mono. You get about 6 dB more gain. That's why we're running at a little over 32 dB versus not quite 29 dB. So I guess maybe it's more like 3 dB of gain increase when you go to a mono situation. And for the purposes of this demonstration, we'll just kind of keep it at that. And it's really easy to compare the two channels. You can see we've got about 15 dB better SNR on the original. THDs, looks like the recapped one is a little bit better, but we're talking 0.02% better, not a big deal there. And the other thing is the THD plus noise. the right channel original one is just slightly better. So overall, they look pretty much the same. I'm going to go ahead and just turn off the left channel so you can see the right channel there, and you can see the 60 hertz hum is a little bit lower on the right channel, which has all the original capacitors. Bring in the left channel, and there you can see that the 60 hertz and 180 hertz spurs, I call them, related to power supply, are higher in the recapped unit. In case I hadn't mentioned it earlier, I have been using the balanced inputs for all of my testing. And here are the harmonics for when the left channel is the RA7503 and the right channel is the RA7501, and they're both putting out 5 watts into 8 ohms as monoblocks. And you can see that the odd harmonics, the third harmonics, are higher than the even or second harmonics. Once again, we're looking at the THD SNR plot at 1 kilohertz with the RA7503, which is our left channel, and the RA7501, which is the right channel, connected as monoblocks, and I'm using the balanced inputs on both of them. The gain went up when I went over to monoblock for about 3 dB, and the right channel is just a little bit less, the 7501, than the left channel, and that's why the power is different. I could push this power higher, but I don't want to trip the circuit breaker that both of these guys are plugged into at the moment. And you can see, as we have seen throughout the testing, that the right channel, the 7501 with all original caps, is running with a better SNR than the left channel recapped 7503, and the THD's a bit better, although you're not going to hear either of those. And the THD plus noise also is better. Now, if you just kind of look at the plot here, if I get rid of the left channel, you can see the right channel is, its peaks are lower than the left channel. Put that back on again. Here is some data showing what the power meters indicated, the LEDs, versus what I measured. And looking over here, and we're just looking at the left channel, and we can see that it's pretty good overall for what the power was versus when the LEDs came on. It's a little bit off here at 25 watts, but it's pretty darn close. One thing I discovered later was that the power meter circuit is based on the input and not on what is actually being measured at the output. Just kind of accidentally discovered that without paying attention to the schematic, but that's what is going on, and it's pretty accurate all in all. And then when I went into mono mode and it's hooked up to 8 ohm loads, it was off a little bit more, you can see, but overall it's not too far off when it's in mono, but it's not as accurate in the mono mode versus being in stereo mode. After I had finished all my bench tests and I hooked it into my system to replace the RA7501, I noticed with no music playing that I was hearing a sound that shouldn't be there, a noise, a high level hiss, I'll call it. Unfortunately, it turns out to be at 2.3 kilohertz, actually 2321.78 kilohertz. And it's loud enough that my ears could pick it up. I don't think that most people would hear it, but I do have fairly decent hearing still at this age. And unfortunately, I heard it. Now, it turns out that it is the 2 kilohertz clock, which actually is a little bit off frequency, that is used by the RA7503 to work the spectrum analyzer circuitry. It sweeps the bands back and forth, I guess. And that is what we're seeing here. And you can see that it's at minus 64.44 dBV. So it's still down there pretty low, but I was able to hear it. My good buddy Ian was over, and once I pointed out to him to listen to it, he could barely hear it. But it's way down there, and with music playing, you won't hear it. It's just something you could hear when there's nothing going on with the music at that particular point in time. I did some playing around and determined that it was that 2 kilohertz clock signal. And here you can see with the 2 kilohertz clock signal disengaged from the circuit. Basically, there's a op amp
and I removed it, and you can see that everything looks really nice with that guy removed. So it's definitely related to the 2 kilohertz clock signal. I did some playing around and shielding, and the wires from the volume control run right along the 2 kilohertz clock signal board that's on. I ended up buying some different cable. It was some shielded cable like twisted pair, and then it was shielded. I installed that, I rerouted it, and you'll see photos of that later on. And I was able to pick up about a 10 dB improvement, and this kind of shows what it looks like after all was said and done. Now I'm showing the left channel as well, but you can see it's just on the right channel, and it's improved by about 10 dB, and I don't hear it anymore. So that's the good news, and it's working well. So here is where I replaced the twisted 3-wire pair with a twisted shielded 3-wire pair, and I soldered the shield to the case right here, and you can kind of just see the wires here. Now I changed the routing of it from going down this way to over this way, and you can kind of just follow that here, and there are some places for it to go through, and then it'll come over here and down, and you'll see where it connects to. So this is at where the input signals come in, and it's part of that board where the volume control sits in. And what I did is I just removed that twisted 3-wire pair right here. You can see the left channels here, and that one worked fine, and I just soldered the end of the cable to the appropriate points here, and then it's soldered to the ground here, and it did a pretty good job overall, as you saw in the test data.
In case you were wondering, I did test the accuracy of both the power meter and the spectrum analyzer, and the spectrum analyzer was dead on as far as indicating the appropriate frequencies. Now the power meter is also dead on, but what happens is that the LED will start glowing a bit before it reaches the power level. So if it was the 25 watt LED, it could start glowing at say 18 watts, and by the time you're at 25 watts it would be at full brightness. So that's kind of how it worked. I only tested the power meter at 1 kilohertz, so at least at 1 kilohertz it worked just fine. If you're listening to your music very low, you would adjust the gain of the spectrum analyzer. I think they call it the spectrum analyzer position. You would increase that so that the unit is more sensitive, and if you're playing at really loud levels you would decrease that. And that's quite common with spectrum analyzers and equalizers and that you have to adjust the gain depending on the level of the input signal. The test data showed that both units were pretty comparable. Now the original 44-year-old unrefurbished RA7501 I thought performed a bit better. It seemed to be a bit cleaner, and part of that was because this guy's spectrum analyzer clock signal, that 2.3 kilohertz signal, was leaking into some of the right channel, and so its SNR was not as good. But in the grand scheme of things, you're not going to hear that. It's pretty far down. It kind of shows that Soundcraftsmen knew what they were doing when they built these things way back when. You know, it's a nice unit. I like watching the LEDs move and knowing how much power I got and what frequency my music is at. But it's a nice addition to one of my listening rooms, I guess I would call it. And they're a good unit. And once again, I would always recommend these. I like Soundcraftsmen gear. I think they did a good job. And this video kind of demonstrates that with how well the original unit performed. If you liked the video, of course, thumbs up. If you have not subscribed to the channel, I hope you will do so. And until next time, I hope you have a great day or night.